this is Dr. Sridhar back to you with another video session on one important parameters of slip and torque. And in the three-phase induction motor is a self-starting device, and one unique property it has is it is having some slip. Now, why? What is the reason this for the slip means? Always rotor is always behind the synchronous speed. Means synchronous speed is the speed attained by the rotating magnetic field. Rotor always try to reach the synchronous speed. So in this process, there will be a difference in the speeds between rotating magnetic field and the rotor speed. Now this difference makes us a slip frequency or slip speed. So that is nothing but like how that slips comes into picture in the three-phase induction motor. So, and one more important property, it may be a property or it is a uniqueness of this three-phase induction motor. It is a self-starting device. So once the motor is switched on, automatically it picks up the speed, and within known time it will reach to a rated voltage or rated speed. So that's why this three-phase induction motor can be called as a self-starting device. So here there are two unique properties this three-phase induction motor is having. One is torque and one is the slip. So in this video session, I am making an attempt to develop the relation between the torque and slip. That is nothing but the torque slip characteristics of an induction motor. The torque slip characteristics is represented by a rectangular hyperbola. So if you could see the characteristics, it will be completely different. So for our convenience, what I am doing is I am dividing the characteristics into three different categories. If the slip is very low, and if the slip is medium, if the slip is high range. Or what is the range of the slips means? Now in the low range value, slip may be 0. In the high range value, slip may be 1. So only the slip, it will be changed its value from minimum to the max one, that is S is equal 0 and S is equal 1. So, but finally what happens, the characteristics between the torque slip or slip torque characteristics are, it gives us the rectangular hyperbola. So this, in order to elaborate this, we have divided this torque slip characteristics into three regions: low slip region, medium slip region and high slip region. So before starting to these characteristics, let me understand what is this torque equation of the induction motor. So in our previous videos also many times we have discussed about what is the expression for the torque. So torque is nothing but the K times of slip into R2 into E2 square divided by R2 square plus S times of X2 whole square. So this K is nothing but this 3 by omega S, that is omega S is nothing but the 2 pi into Ns, that Ns is nothing but the synchronous speed. So you need not write so many times that 3 by K is nothing but 3 by omega S, not required. Only that's why I am representing K, T is equal to K into S into R2 E2 square divided by R2 whole square plus SX2 whole square. So except this 3 by omega S, why I am not writing K is equal to 3 by omega S means, in that one omega S is equal to 2 pi Ns, Ns is nothing but it is a synchronous speed, always it will remain same. Once the motor starts, now from there onwards that synchronous speed remains same. So that's why I am not writing Ns. So torque is equal to the remaining values, torque is directly proportional to S into R2 E2 square divided by R2 whole square plus SX2 whole square. So in the low slip region, now at the synchronous speed, the slip is equal to 0. Therefore, the torque is close to 0. Now, because the torque is directly proportional to slip into R2 into E2 square. So if slip is in the low range value, means it is close to 0. Then whatever the torque will also 0. When the speed is very near to the synchronous speed, the slip is very low and SX2 whole square is negligible in comparison with the R2. If you could observe the denominator, in the denominator R2 square plus SX2 whole square. If the slip itself it is close to 0, then SX2 value is almost of a negligible as compared to the R2. So in the denominator you will get the R2 square, in the numerator S into R2 into E2 square. So S into R2, and in the denominator R2 square is there, 1 R2 gets cancelled. So remaining one is the torque is nothing but the K1 into S into divided by R2. Why K1? Why not K means K1 into E2 square is there. So let us simplify that by keeping one more extra constant, that is K1. If R2 is constant, the torque becomes torque is equal to K1 into S. It is clear that the torque is proportional to the slip. Now, if you could observe this particular expression in this one, if somehow let us assume R2 is also not that much influenced parameter, if R2 is also a constant, then torque is directly proportional to slip. Means whenever the slip is in the minimum range, it means in the slip is in the low range values, then the relation between the torque and slip is nothing but the linear relation. That's what we want to highlight here. So for the low slip range, the relation between the torque and slip is nothing but it is a straight line. So now next range is nothing but the medium slip range. If the slip increases, the speed of the motor decreases. It is very clear because the slip is nothing but synchronous speed minus rotor speed to the synchronous speed. Now if the motor picks up or the slip increases, if the slip increases means this is constant. So how the slip it will be increased? Now provided that the speed of the motor should be decreased. So how the speed of the rotor it will be decreased? If the load increases. This is the sensitive relation between the load and the rotor speed and the rotor speed and the slip. So in this case, whatever the Sx2 whole square. Now if the slip increases, means Sx2 whole square in the denominator it will be considerably large. Then the term R2 square, in that cases R2 square may be negligible. Then what could be the torque value now? Torque is equal to S into some constant S into E2 square into R2 divided by anyhow R2 square it can be negligible. So S square into X2 square. S gets cancelled. So remaining one is nothing but torque is directly proportional to K2 into S. So in that cases the torque equation becomes inversely proportional to the slip. Now this value is nothing but K2 by S, not K2 into S. This is K2 by S because in the denominator S will be there. So if the slip increases, torque decreases, torque increases, slip increases. That is the relation now. So that is finally what could be the torque here. Torque is equal to K3 into R2 divided by S into X2 square. So the relation is nothing but the inverse relation. Now if you could see here, now for medium range of values or this SM is nothing but that is the slip for the maximum torque. Or the now on x-axis if you could take the slips and y-axis if you could take the torques. Now for the lower range values of the slip, now these are nothing but the linear relations. The relations are nothing but the exactly linear. Now see, in this particular region, the relation between the torque and the slip is linear, and if the slip furtherly it increases, then inverse relations is appearing here. So this is nothing but the inverse relations. It means now if the slip goes on increasing, the torque is nothing but it is moving in the downward direction. So this is nothing but the inverse relation it is happening. So next I slip region. So beyond the maximum torque point. So this is nothing but the maximum torque point. The value of the torque starts decreasing. So that is the based on the slip range. Now because what I want to convey you is not always the slip and torque is uniform. The relation is it will be not continuously it maintains the same thing between the slip and torque. So if the slip value also highly influences the torque produced by the motor. So the motor operates for the values of the slip between S is equal to 0 and SM. Means here from 0 slip to SM, that SM is nothing but the maximum value of the slip. Now, not the maximum value of the slip at the maximum torque. Now within this range the operation is linear, but whenever once it crosses that SM value, SM is nothing but that is the slip corresponding to the maximum. Now it will be influenced by the resistances. So if the resistance is too high, the torque will be now attaining the torque to a maximum value, it will be delayed. So that's why these resistances are also very, very important. If R23 is nothing but it will have more linear, and if the resistance is considerably less, then it will be the linearity is nothing but very, very shorter periods. So this is nothing but starting torque. So initially how much of torque it will be there, that is starting at the starting condition the slip is nothing but that is a 1. So at slip is equal to 1, whatever the starting values. Now for the second resistance R22, this is nothing but the starting torque. For R23, this is the starting torque. Now this is nothing but finally this is the maximum torque. It means for R2 is equal to X2 naught, that is the condition to achieve the maximum starting torque. Otherwise, this is the point where we are going to get the starting torques. Torques are nothing but the starting torques. This is a very rectangular hyperbola characteristics. This is the unique characteristics three-phase induction motor is having. So this is the slip torque characteristics. That is a very beauty of this torque is the characteristics. The beauty of this characteristics of three-phase induction motor is never the relation between the torque and slip is uniform. It will vary with respect to the slip value. I hope you enjoyed this video session. Thank you very much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.